If you have ever placed a straw into a glass of water, you have probably noticed it appears bent at the point it enters the water. This optical illusion is due to refraction and reflection. As light passes from one transparent medium to another, it changes speed and is refracted. How much this happens depends on the refractive index of the medium, while the reflective index is how much of the light hits the outside of the medium and is bounced off or reflected. Each medium has a different refractive and reflective index. This is called the law of refraction and reflection, which is also known as Snell's law. Snell's law compactly describes what happens to the trajectory of a beam of light as it passes from one medium to another. Light amplification by stimulated emission of radiation, or just laser, is a mechanism for emitting electromagnetic radiation by the process of stimulated emission. The emitted laser light is a spatially coherent, narrow, low divergence beam that can be manipulated with lenses. In laser technology, coherent light denotes a light source that produces light of in-step waves of identical frequency, phase, and polarization. The laser's beam of coherent light differentiates itself from light sources that emit incoherent light beams of random phase varying with time and position. Laser light is generally a narrow wavelength of electromagnetic spectrum of monochromatic light, usually red. Yet there are lasers that emit a broad spectrum of light or emit different wavelengths of light simultaneously. Lasers are seen more clearly than typical light when passing through a medium. This is because all the light is focused in a tight beam and it can easily be seen bending through the medium. This is because the change in the speed that the light travels towards the perpendicular and away from it. The laser can leave one medium and go into another and change its direction, but if it re-enters the original medium from the other side, it will go back on its original path. For my experiment, I will be investigating how much of a reflective index different mediums have. I will be testing water, gelatin, and milk. The laser passing through the empty container will be my control group. My questions were, what is the refractive index of a laser passing through a clear plastic bowl? And my second question was, how much does the reflective angle change when the bowl is filled with water, milk, or gelatin? My first hypothesis was that through the plastic container, the reflective angle will be between 10 and 30 degrees. My hypothesis for my second question was that when the bowl is filled with water, it will have a slight increase, and when it's filled with gelatin, it will have a large increase. I did not believe that the laser would not reflect off the milk. To begin this experiment, I purchased some clear Kroger brand gelatin from the grocery store. All the other materials, the plastic container, the laser, protractor, Kroger brand 2% milk, and water I already had. I mounted my laser on a rubber eraser with tape to steady the laser. I first measured the empty plastic container. I shot the laser into a small hole I drew on the side of the plastic container. I would then use the lines on the index card to see where the laser hit and follow them down and mark it on a sheet of paper. I then used my protractor to measure where the angle hit and where it ended up. I did this exact same way for the water and the milk, and between each test, I made sure that the container was thoroughly cleaned out. I prepared the gelatin according to the instructions on the back of the box and let it sit overnight in the refrigerator. I then, the next morning, did it the exact same way. I took 3 readings of each medium and then averaged them together to get a more accurate reading. The results were as follows. The empty container yielded reflective angles of 126 degrees, 140 degrees, and 99 degrees, averaging 121.7 degrees. The water test results were 150 degrees, 137 degrees, and 126 degrees, averaging 137.7 degrees. The milk gave results of 131 degrees, 115 degrees, and 131 degrees again, averaging 125.7 degrees. Finally, the gelatin resulted in 149 degrees and 150 degrees, averaging 149.5 degrees. There were only 2 results for the gelatin test because one of them was inconclusive. In conclusion, my first hypothesis that the empty container will have an reflective index between 10 and 30 degrees, it was wrong. In fact, averaged 121.7 degrees. My second hypothesis was partially correct. I was right in that the H2O would have a slight increase and the gelatin would have a large increase. The water had an increase of less than 10 degrees and the gelatin had an increase of over 30 more degrees than the empty container. I was, however, wrong in my statement that the milk would not be able to reflect the laser light, and in fact reflected it at 125.7 degrees.